Hi everyone, welcome to lesson 17. I would like to tell you right now that this lesson is definitely split into two parts. This lesson will be about solving systems of equations. There's actually three methods for solving systems of equations, and for now we're going to focus on just two of the three. So a system of equations is more than one equation put together. So the ones we will be focusing on will be systems that have two equations and two variables. And usually those two variables will be x and y. There are other systems of equations that could have three or more variables, but we will not see those in this class. All right, so what you're seeing on the screen now is a method of solving that involves graphing, and that's not actually what we're going to focus on for now. We will be focusing on algebraically solving them, meaning we will use algebra to solve systems of equations rather than graphing. For now, that method will be covered in Math 0931. So when you move on to Intermediate Algebra Part 2, you will learn how to solve systems by graphing. But for now, the two methods that we're going to focus on are called substitution and elimination. So this first video will focus on substitution. But before I move on and show you that, I do want to just quickly address what you're seeing, which is graphing. So there's two equations here. X plus y equals 5 is the first one, and that's in blue. And the second equation is y equals 2x minus 4. So if you think about the first equation, x plus y equals 5, there's many possible solutions to that equation. In other words, there's a lot of numbers that exist that add to 5. For example, 1 plus 4. That's 5, right? Or 2 plus 3. Those add up to 5. Or 6 plus negative 1. That adds to 5. I could go on literally forever. There's an infinite list of possible numbers that would add to 5. And the blue line that you're seeing graphed here represents all of those possibilities. Each possibility would be a point that you graph on these axes. There's the y-axis going up and down, and there's the x-axis going side to side. And I said we weren't going to cover graphing right now, and we're not officially, but I just briefly wanted you to see one sort of representation of a system of equations. So the blue line represents all the different possible combinations of numbers that could add to 5. So for example, if you have 1 plus 4 equals 5, there's a way of representing that on this graph. You would have the point 1, 4. 1 would be on the x-axis over here on the right, and then 4 would be up here on the y-axis. And then I'm kind of drawing a point right there in that physical location of 1, 4. So you'd go 1 to the right and then up 4 on your graph. We could do that with every possible combination of numbers that add to 5. So if we keep doing that, you'd see a bunch of points that when you connect them would form that blue line. Great, okay, so then if we move on to the red line, y equals 2x minus 4, there's an infinite combination of numbers that would make sense in this equation as well. And I'm not going to list them right now, but I just want you to see that that's what this red line represents. Now, the main takeaway from looking at this graph example, kind of out of nowhere, because you haven't officially learned how to graph lines, and that's okay. The red line and the blue line intersect each other at only one point. So for most of the systems of equations that we're going to see, there will be one pair of numbers that will work for both equations. So as I was saying, there's an infinite number of possibilities of numbers that add to 5, right? So for that first equation, x plus y equals 5, there's so many combinations that would work. If I ask you, what are two numbers that add to 5? There's more than one answer for that. But as soon as you put that equation with a second equation, suddenly it really narrows it down, and there's only one possibility that of two numbers that will work for both equations. And if you're familiar with graphs at all, you'll see that the point that I just circled in yellow here is 3, 2. So kind of giving away the answer here, but our solution to this system of equations would be the point 3, 2. 3 is our x value, 2 is our y value. So there's two variables now. So you can see that works up here in the first equation. 3 plus 2 is 5. If we plug in 3 for x and then 2 for y, we would see that the second equation would also have 3, 2 as a possible solution. We'll get to that after we solve this equation using a different method called substitution. So I just kind of wanted to give you a preview of graphing, because you will eventually see this as a way of solving. But for now, let's move on and we will look at the algebraic way of solving systems of equations. So there's two methods. We're going to start by using something called substitution. So I have a list of steps here. Step 1, isolate one variable in one equation. So what we have below and under where it says examples are number 1. It's the same exact system of equations that you just saw graphed. Okay, so it's x plus y equals 5 and y equals 2x minus 4. Notice that in the second equation, y is isolated. Y is by itself. So that's step 1, isolate one variable. That's already done here because y is already isolated by itself. Step 2, substitute into the other equation for the variable you solved for. In other words, you're going to plug in. So in our problem here, since y is equal to 2x minus 4, what we're going to do is substitute or replace y with 2x minus 4 in the other equation. So what I'm going to do next is I'm going to rewrite that first equation, but instead of writing x plus y equals 5, I'm going to write x plus, then I'm kind of leaving a space. I'm writing some parentheses, equals 5. And in that blank space, I'm substituting for y. So instead of writing y, I'm replacing y with 2x minus 4 from that second equation. So because y equals 2x minus 4, I'm replacing y or substituting y with 2x minus 4. So by doing this, we've changed our problem from two equations with two variables to suddenly, now it's one equation with only one variable. Now it's all just in terms of x. So the equation we have right now is x plus parentheses 2x minus 4, close parentheses, equals 5. Okay, so we've now done step 1 and step 2 in our list up here. We isolated one variable in one equation. We did that already. It was kind of already done for us. We just did step 2, substitute into the other equation for the variable you solved for. So that's when we substituted for y. And now step 3, that's going to be the most work. Solve this new equation. So take all the skills we've built up to this point in terms of solving for x, and we're going to apply them to this equation. So let's solve the equation. X plus 2x minus 4 equals 5. Now I had the 2x minus 4 in parentheses. That wasn't exactly necessary here because there was no number in front of the y, but if I wasn't just replacing y, if let's say it was 3y, I would need to keep the 3 and then keep the parentheses, and I would need to distribute the 3. So sometimes the parentheses will be necessary, which is why I will recommend anytime you're substituting for a variable, just immediately put parentheses. And then if you don't end up needing them, that's fine. If there's a number there, then you know to distribute. But for us, there's really no number there other than an invisible 1, so you can kind of distribute the 1, I guess. I'll just rewrite the problem now. x plus, and then if I distribute a 1, 1 times 2x is 2x, and then 1 times minus 4 is minus 4. So x plus 2x minus 4 equals 5. Now let's combine like terms. X plus 2x, that's 3x. So I have 3x minus 4 equals 5. Now let's add 4 to both sides. 3x equals 9. And then we'll finish solving for x by dividing by 3, and x equals 3. Usually we're done when we find x, right? That's kind of what we just did, kind of feels like we did a whole complete problem. However, that's really not the case right now, because if we go back to our list of steps, that was just step 3 out of 5. So what do we still need to do? Let's see. We solved the new equation. We got x equals 3. Step 4 says substitute into one of the original equations and solve for the other variable. Okay, wait, what other variable? Oh yeah, there's y. So since we found x already, we need to find y. So we can substitute into either one of the original equations. It does not matter which one. Sometimes one will seem easier than another. I think I'm going to actually do the second one because since I'm trying to find y, it's handy that I have an equation where y is already by itself. So I'm going to plug in or substitute into that second equation, y equals 2x minus 4, except this time I'm plugging in for x, or I'm replacing x with the answer that we got, which was 3. So instead of y equals 2x minus 4, I'm writing y equals 2 times 3 minus 4. Now let's simplify. Y equals 2 times 3 is 6 minus 4, and then 6 minus 4 is 2. So y equals 2. Okay, so notice that we found x was 3, and then we just found that y was 2. We're almost done. We have a complete answer. The answer to a system of equations is something called an ordered pair. And ordered pairs are often points that are plotted on a graph, and I was attempting to show you that before. We're not going to be plotting these on a graph right now, but what we will do is we'll write our answer in order. That's what the word ordered means. Order matters. We have parentheses, and then we always list the x coordinate first. So since we got x equals 3, I'm going to write parentheses and then 3 and then a comma. Then we write the y coordinate, which is 2. So I'm writing parentheses, 3, comma, 2, and then close the parentheses. This is our final answer, 3, 2. The very last step is to check our answer. So we're going to check the solution in the original equations. Okay, so we're going to check in both equations. I'm going to take us to a blank screen to do that. Okay, so we're about to check. So we had y equals 2x minus 4, and the first equation we had was x plus y equals 5. And let's see, the solution that we got is 3, 2. Okay, so we need to check both equations. First, let's check the first equation. So I'll just call that equation 1, x plus y equals 5. X plus y equals 5. I'm plugging in both of my numbers that I got in my ordered pair. So I'm plugging in 3 for x and 2 for y. So let's replace x with 3. So instead of x plus y, I'm going to write 3 plus, and then I'm replacing y with 2. So 3 plus 2 equals 5. So now let's check if that actually is true. 3 plus 2 is 5. 5 equals 5. Yes. So my solution checks in the first equation. Now we have to check in the second equation. So I'm just numbering that number 2, equation number 2. You need to be careful about checking in both equations. Okay, so if it works in one but not in the other, you might have missed a mistake at some point. So it is important to check both. So that's what we'll do next. Our next equation is y equals 2x minus 4. This time, let's replace x with 3 and y with 2, just like we did before. All right, so y equals 2x minus 4. Okay, so y is 2. So I'm going to write 2 equals, instead of writing 2x, I'm writing 2 parentheses 3. So in other words, 2x means 2 times x, so I'm writing 2 times 3. And then there's still the minus 4. Now let's simplify on both sides. There's nothing to do on the left side, just leave that as a 2 equals. And then 2 times 3 is 6 minus 4, and then 6 minus 4 is 2. So I'm getting 2 equals 2. So the solution checks in both equations because when I replace x with 3 and y with 2, each equation ends up being true. You get something equal on both sides. So that's an example of solving a system of equations using substitution. So we had a variable by itself, and then we substituted into another equation. We worked through it and found a variable. In this case, we found x first. Then we were able to go back and find y. And finally, we had to check our solution at the end. All right, so can you tell the problems are getting longer? But you knew that would happen, right? Okay, that was example 1. Let's go to the next one. Here's example 2. 2x plus 2y equals -3. And then 2x minus y equals 5. So to use substitution here, our first step, remember, was to isolate a variable, to get a variable by itself. Now that's not done for us yet in this problem. So we really need to think about this. Now I'm thinking, and you're not hearing what I'm thinking. Okay. What I'm looking at right now is I'm noticing what are the coefficients or the numbers in front of each variable. What I would like to find is a variable that just has nothing in front of it or just a 1 in front of it. So in other words, this 2x or 2y in the first equation, I don't really want to deal with solving for either of those because I'll end up needing to divide everything by 2, and then that will lead to a fraction, which I'd like to avoid if possible. So let's look at the second equation, 2x minus y equals 5. I want to focus on that minus y. Let's see if we can solve for y. In other words, we're isolating y in that second equation. The coefficient or the number in front of the y is, it just looks like a minus sign. It's really a -1. So we will eventually need to divide everything by the -1 or the -1, but that's okay. Dividing by 1 does not lead to fractions. So I think this will be our easiest option. So we're going to solve for y with that second equation. So let's give that a try. So think about what we did in that formulas lesson, I think it was lesson 13, where we were getting variables by themselves. That's what we're doing right now. So we have 2x minus y equals 5. Let's work on getting y by itself. So I'm going to subtract 2x on both sides. So then I have minus y equals, and then on the other side, you can write 5 minus 2x, or I'm going to write -2x plus 5. Either way is fine. To finish solving for y, I don't want that minus sign in front of it, so I'm going to divide by -1. And I do mean divide everything by -1. So now I'm going to have y equals, instead of -2x, now we have just +2x. And then instead of +5, now we have -5. So we finished solving for y, so we have y equals 2x minus 5. That was already quite a bit of work, and we haven't even really started yet. But we've done the first step of isolating a variable. Now we get to substitute or plug in. So what does that mean? What are we substituting? What are we plugging in? All right, so we have y by itself, y equals 2x minus 5. We're going to substitute in the other equation. So whichever equation you haven't used yet, that's what we substitute into. If you just plug into the same equation, that will get you nowhere. You'll end up kind of going in this endless cycle and you will not end up getting a full solution. So we absolutely need to substitute into the other equation, which means, let's go back to the first equation and we're going to replace y with 2x minus 5. Okay. So when I rewrite, let's see, we're going to have, instead of 2x plus 2y, we're going to have 2x plus 2, and then parentheses. The parentheses is kind of taking the place of the y. And in those parentheses, that's our substituting, that's our replacing. And remember, we're replacing or substituting y with 2x minus 5. And we'll just finish copying the rest, which is equals -3. So putting it all together, we have 2x plus 2 parentheses, 2x minus 5, close parentheses, equals -3. And now we get to solve for x. Okay, so now we've kind of created this one single equation that has one variable, just x, and we get to solve it. So let's see. We have these parentheses. We have a 2 in front of the parentheses. Let's distribute that 2. So 2 times 2x becomes 4x, minus 2 times 5 is 10. Putting it all together, now we have 2x plus 4x minus 10 equals -3. So I distributed, that was the first step. Next, let's combine like terms. 2x plus 4x is 6x. So we have 6x minus 10 equals -3. Add 10 to both sides. If you're working ahead at all, you might start to notice, hey, this isn't working out so nicely. We're going to get a fraction, and that's okay. And if you look at the bottom corner of the slide, I've even put the answer almost like a little safeguard for myself and for you to know that we're on the right track. So here's where we are. We're now at the next step, 6x equals, and then on the other side, -3 plus 10 becomes 7. Divide both sides by 6. So we get x equals 7/6. Yes, fractions are fine. Reduce if possible. 7/6 can't be reduced. Please don't change it to a mixed number. That's just creating extra work for yourself. So, and also don't change it to a decimal. This would be a repeating decimal. You'd have to round it and everything would be thrown off. So leave it as a fraction. X equals 7/6 is the best answer there. Okay. But remember, there's 2 variables, so I just found one of them. We now need to go back and find the second variable. So let's go back and find y. We need to plug in, and I think as I'm deciding where to plug in, you can kind of make a choice about which equation looks easier, and maybe neither of them look easy, but I think I'm just going to choose the second equation to plug in to find y. And it does not matter which one you choose, it would work out fine either way. But that's what I'm going to choose. So 2x minus y equals 5 is what I'm going to choose. Okay, and I'm going to take us to a blank screen to do that. So we got x equals 7/6, and now we're going to plug in to find y. Okay, so here's my next step. Let's see, I have 2x minus y equals 5. We just got x equals 7/6. So let's plug in. Okay, so now instead of 2x, we have 2 times 7/6. So I'm writing 2 parentheses 7/6 minus y equals 5. All right, let's multiply together. So this is really like 2/1 times 7/6. That becomes 14/6, but if you reduce by 2, the 2 and the 6 can be reduced to just 1 and 3. So it ends up being 7/3, or 7/3. So I have 7/3 minus y equals 5. Let's get that y by itself. So I'm going to subtract 7/3 on both sides. Let's see. So now I have minus y equals, and now we need to deal with this fraction operation over here. So 5 minus 7/3, that's 5 over 1 minus 7/3. Let's see, let's get a common denominator. And yes, you can use a calculator, that's fine. But I don't have one in front of me, and I want to practice my fractions. So I'm going to keep going like this. 5 over 1 can be rewritten as 15 over 3. So 15 over 3, and then minus 7 over 3, that's 8 over 3. So we're almost done finding y. So we have negative y equals 8 over 3. If I just multiply or divide both sides by this -1, I know that looks weird to write 8/3 divided by -1, but all it's going to do is change the sign. So don't worry, it's now just y equals -8/3. Okay, so we got x equals 7/6 and y equals -8/3. So that's our ordered pair. Let's go back now and check our answer in both equations. Okay, so we're checking. So 2x plus 2y. So I'm replacing 7/6 for x, and then I'm replacing -8/3 for y. And then that first equation, that was equal to -3. And now we'll just see if that's true. So 2 times 7/6, if I reduce, that's 7/3 plus, and then 2 over 1 times -8 over 3, that's -16 over 3. 7/3 plus -16/3 is -9/3. And if you divide, -9 divided by 3 is -3. And -3 is equal to -3. And now we can just check in our second equation. Okay, now to check in the second equation. So our second equation, that's 2x minus y equals 5. We're going to check our solution there as well. Remember, x was 7/6 and y was -8/3. So 2x will now be 2 times 7/6 minus y. Now be careful here, minus, in parentheses, I'm writing -8/3 because y was -8/3. So minus y becomes minus -8/3. It's going to turn to a plus in a second here. Okay, so 2 times 7/6 minus -8/3 equals 5. That's what we're checking. So 2 times 7/6, we'll put the 2 over 1, reduce like we did before, that's 7/3. Minus -8/3 actually becomes plus 8/3 equals 5. 7/3 plus 8/3 is 15/3. And then if I reduce 15/3, 15 divided by 3 is 5. So I'm getting 5 equals 5, and it works. So I know the checking process is kind of annoying, and I don't blame you if you don't check every time, but you kind of should, and you should know how, okay? So that's why I'm trying to be extra thorough here. And yeah, I just wanted you to see that, yes, you can get fraction answers for x and y, and that is okay. And this, this is kind of hopefully showing why solving by graphing isn't always ideal, because you wouldn't be able to easily see on a graph 7/6 and -8/3. That's 7/6 is just a little more than 1, and it's hard to accurately visualize that. So when your answers are not nice whole numbers like 3, 2, it's especially important to be able to use algebra. So substitution is what we're focusing on. All right, good. So we've done number 1 and 2. Let's see what we got left to go. All right, I'm looking at number 3, 4, 5, and then we'll get to elimination. Okay, just taking a little preview there. All right, so we have number 3. There's a little question on the side. What happens if all variables cancel out? We're about to find out. Okay, so here's number 3. And that little box on the side is giving us a clue that something strange is going to happen here. Here are our equations. Y minus 6x equals negative 8. And the second equation is negative 3y plus 18x equals 4. So let's start just like we did last time by isolating a variable. Let's solve for y in that first equation. So y minus 6x equals negative 8. If we just add 6x to both sides, here's what we would get. Y equals positive 6x minus 8. And then we can substitute into the second equation, into the other equation, I should say. So our other equation is negative 3y plus 18x equals 4. So let's replace the y. So instead of negative 3y, let's write negative 3 parentheses. And then in the parentheses, we're going to replace the y with 6x minus 8. So I have negative 3 parentheses, 6x minus 8, then close the parentheses. Now just finish copying the rest down. It's plus 18x equals 4. Okay, so just like the last couple problems, let's solve for x. Let's distribute that negative 3. So negative 3 times 6x is negative 18x. Negative 3 times negative 8 is positive 24. And then I'll keep copying everything else down. Plus 18x equals 4. Okay, so here's what we have so far. Negative 18x plus 24 plus 18x equals 4. I would combine like terms next. So the negative 18x plus 18x can be combined, but when we combine them, they add up to 0. So I now have 0x, or just nothing. Not nothing altogether, but just the x's cancel. So what do we have? Well, what we still have left is this plus 24 on the left side. So we can just write 24. And then on the right side we have 4. 24 equals 4. That doesn't make any sense, right? That's not true. So what happened? Well, we've seen this happen before actually in some other equations where if the variable cancels out, remember how sometimes we had infinitely many solutions and sometimes we had no solutions? Or sometimes I think we might have said all real numbers. That might have been the phrase we used. So the phrase is going to change a little bit. We're still going to sometimes say there's no solution, and that is the case here. This system of equations has no solution because the variables have canceled out and we're left with an equation that doesn't make any sense. So visually speaking, what would happen if we were to graph these two lines is they would be parallel lines. The lines would not cross at all. They share no points in common. So what we get to say is there's no solution. Now, if we ended up with something like 24 equals 24, and that was true, what that means is your two lines are actually the same. They're the same line and they share an infinite number of points. So we would say infinitely many solutions. And when you do your homework in MyLabs Plus, that will be a choice that you can select if one of these things happens. Usually we'll just get a solution that's an ordered pair in parentheses like you've seen already, but this is one of those rare cases where that was not what happened. The variables canceled out, and so we end up with an equation with just numbers. The number equation, 24 equals 4, was not true, so we had to just say there's no solution, and that's it. There's not really a way to check that. I mean, I can go back and check my work, but there's nothing to plug in. There's no extra variable to find. So this one was a little bit shorter in that way. All right, number 4 and number 5 are the next two problems we're going to do. These are word problem examples. Okay, so here's the first one. You see a picture of a rectangle on the screen. And this is not a geometry class, but there's some very basic geometry that you should be familiar with, such as knowing what a rectangle is. It has 4 sides. 2 sides across from each other are equal to each other, and then the other 2 sides across from each other are equal to each other. The shorter sides are generally called the width. The longer sides are generally called the length. Perimeter refers to the distance around a shape. And there's a formula for perimeter of a rectangle, and it goes like this. 2L or sorry, let me say the whole thing. P equals 2L plus 2W. L stands for the length, W stands for the width. I'm going to go ahead and label that on my rectangle here. So W on either side, L on the top, L on the bottom. Our rectangle is kind of longer in that side to side direction. Okay, so there's 2 lengths and 2 widths, and if you add those up together, you'll get the perimeter. Let's actually read the problem now and see how we can solve this. Okay, so it says a rectangular field has a perimeter of 48 meters. The length is 3 times the width. Find the length and width of the field. Okay, so probably want to read that again, but what I would like it to tell you is we need to now come up with our own system of equations based on the words we just read. The first sentence will give us our first equation. So a rectangular field has a perimeter of 48 meters. Okay, so I can write 48 equals 2L plus 2W. And if you can't tell already, I'm using L and W instead of X and Y. If you don't like that, you can replace the variables with X and Y if you prefer, it doesn't matter. But I like using L and W because it helps me keep track of which is which at the end. Okay, let's read the next sentence. The length is 3 times the width. So when we say the length is, that's kind of like L is or L equals. So my next equation will start with L equals. So the length is what? Okay, the length is 3 times the width. Okay, so 3 times the width, that can just be 3W or 3 times W. And now we have it. We have our system of equations. We have 2 equations with 2 variables. The first equation is 48 equals 2L plus 2W. The second equation is L equals 3W. So now let's try to follow the steps we've seen already. Do we have a variable isolated by itself? We do actually. That second equation, L equals 3W. L is by itself, so that's all set. So now we can substitute. Now we can plug in for L in the other equation. So I'm going to go and replace L with 3W in that first equation. So here's what it looks like. Instead of 48 equals 2L plus 2W, it's going to be 48 equals 2 parentheses, and in the parentheses, let's write 3W. And then finish copying down, plus 2W. Okay, now let's simplify. 2 times 3W is 6W. So now we have 48 equals 6W plus 2W. Just combine those together. 6 plus 2 is 8, so 48 equals 8W. Just divide both sides by 8. I'm almost out of space. It's not letting me do it. All right, and then 48 divided by 8 is 6. So we're getting 6 equals W, or W equals 6. That's our answer for the width. So now let's find the length. Let's plug in. Looking at our 2 equations, I think that second one looks easier. L equals 3W. Let's just plug in. L equals, instead of 3W, we can do 3 times 6. And 3 times 6 is 18. So it looks like we've gotten 6 for the width and 18 for the length. And by the way, we're using meters, I guess, for our units. That's going to be typed in already for you on the homework, but it's just good to know what meters or what units you're using. In this case, it's meters. So the width is 6 meters. The length is 18 meters. Now, how are we supposed to check this? Well, we have a little picture happening here. Let's just label our diagram. So for each of the widths on the rectangle, I'll just put 6 meters or 6 on each of those sides. And then for the length, I'll put 18. So let's just see if this makes sense. I have 6, 6, 18, 18. Let's add those all up. 6 plus 6 plus 18 plus 18. That's our perimeter. And that should add up to 48. So let's just check. 6 plus 6 is 12. Plus 18 plus 18. 18 plus 18 is 36. 12 plus 36, yeah, that's 48. So it checks in that first equation, or not even in the equation really, it checks in the diagram itself. But if you look at the first equation, 48 equals 2L plus 2W. If we plugged in 2 times 18 plus 2 times 6, you'd end up getting the exact same situation here. The 2 times 18 is the 36, and the 2 times 6 is the 12. It would still work out. Okay, and then if we check in that second equation, L equals 3W, well, let's check. 18 equals 3 times 6. Yeah, that's true. Okay, so still good to check. If your problem has to do with some kind of a shape that you can draw and visualize, use that to your advantage to kind of add an extra layer of understanding what's going on, and you can use that to help check if your answer makes sense. All right, good. So we just solved a word problem with perimeter. So we use the formula P equals 2L plus 2W. We set that 2L plus 2W equal to 48 because the perimeter was 48 meters. Then we kept reading and we saw the length is 3 times the width. So we used L equals 3 times W for our second equation. And then we were able to substitute from there. Okay, so that was problem number 4. We'll do one more geometry type problem. This is number 5. You'll see some problems with angles. The words that you'll see will be defined for you in the homework, so that's helpful. So number 5 says, supplementary angles are angles whose sum is 180 degrees. Okay, so we're gonna have two angles. We'll call them X and Y. They're supplementary, so that means they add up to 180. Sum means adding, right? So just the word supplementary pretty much gives us our first equation, X plus Y equals 180. And I haven't even read the full problem yet. All I read is just the definition of supplementary. And over here in my little diagram, that's not really necessary. I just have two angles that when put together, they're forming this horizontal or straight line. All lines are straight. I don't really like saying that, but they're forming a line. They're forming a, they're forming a straight line. That's what a 180 degree angle looks like. It's kind of a half circle, I guess, if you go around like that. All right, so X plus Y equals 180. Let's read the full problem. So it says two supplementary angles are such that one angle is 3 degrees less than twice the other. Find the angle measures. Okay, reading it again. Two supplementary angles. That right there, it's not a full sentence, but it's a definition. That's your first equation right there. So just the phrase two supplementary angles, right away what you can write is X plus Y equals 180, based on the definition of the word supplementary. In your homework, if you see the word complementary, that means they add up to 90 rather than 180. I'm going to keep reading. Two supplementary angles are such that one angle is 3 degrees less than twice the other. Okay, so one angle is, well, something is, let's see, the word is can mean equals. I'm just gonna say Y equals. It does not matter if it's X or Y. So Y equals, now let's be careful about what comes next. One angle is 3 degrees less than twice the other. Okay, so the other means the other angle. Twice the other, that would be 2x. 3 degrees less than that would be taking 3 away from something. So the next equation we're going to write is Y equals 2x minus 3. Read that one more time. Y equals 2x minus 3. That's 3 less than twice x, or 3 less than twice the other angle. So Y equals 2x minus 3. Okay, now let's actually solve using substitution. Y is by itself. We have the Y equals 2x minus 3. So let's substitute into the other equation. I'm going to go back to the first one. Instead of x plus y equals 180, now I'm going to write x plus, and then in parentheses, instead of y, now I'm substituting 2x minus 3. equals 180. Okay, so x plus 2x minus 3 equals 180. I had the y expression in parentheses. There's no coefficient in front of it. I don't need to distribute anything. So the parentheses are not really necessary. So I can go ahead and just combine like terms. X plus 2x is 3x. So I'm writing 3x minus 3 equals 180. Now let's add 3 to both sides. Oops. So now we have 3x equals 183. Then divide both sides by 3. So we end up with, let's see, x equals 61. All right, we found x. Now let's find y. If I use that second equation, y equals 2x minus 3. So let's substitute 61 for x. So y equals 2 times 61 minus 3. Y equals 2 times 61 is 122, and then 122 minus 3, that would be 119. Okay, so we did it. We found two angles. We do need to check. Now, I want to tell you a slight shortcut for checking. Be really careful about this. I know I told you to check in both equations, and you should, but if you want a little shortcut, you can just check in the equation that you did not most recently use. So see how I just plugged into the y equals 2x minus 3? I don't need to check it in that one because I just used it, okay? And if I did check, it would just be replacing the x with 61 like I just did and replacing y with 119. And I'd end up getting 119 equals 119. What I haven't used lately is the other equation. So I'm going to check in the x plus y equals 180 equation. And so let's just plug in what we got. We got 61 for x, so 61 plus, and then we got 119 for y equals 180. Okay, and if you add those up on your calculator or just write it out, then we'll know we did it. So just adding here, yes. So 119 and 61, they do add up to 180, so they do work as supplementary angles. And we also checked, or we also used the other equation about being 3 less than twice the other. So one angle is 3 less than twice the other. That's why we use that y equals 2x minus 3. So the 119 is 3 less than twice the 61. It sounds worse than it looks when I say it like that. So, okay, good. So I know you were probably not expecting to deal with triangles, or excuse me, with angles and rectangles, but there you go. So you need to know the perimeter formula for a rectangle. You need to know that supplementary angles add up to 180, and then you'll also see complementary angles adding up to 90. Other than that, I don't think there's any additional geometry you'll need to know. But it's just something else to get familiar with. So what comes next in our PowerPoint here is moving on to another method of solving, which is called elimination. And we would normally save that for another class period. So we usually spend one class period on substitution, what we were just talking about, and then one class period on elimination. So I'm going to end here. I strongly encourage you to go to homework 17 and work on it, okay? So there's a lot in there. About half of the problems, the first half, can be done using substitution. And then the second half will focus on elimination. So please go start that. Try to get at least the first half done, and then you'll feel that much more ready to come back and learn about elimination next. Okay, and we'll end up sort of deciding which method is better in which situation. It's good to know both because some problems will be easier done one way than another. So, all right, very good. Well, give yourself a break and then go try some of those homework 17 problems, and I'll see everybody soon. Thank you.